Hi, everybody. Hi, welcome to the second day of Angular Connect. I talked to many of you yesterday and heard that you had an awesome day. I hope that today is going to be just as awesome, if not better. My name is Igor Minar, and thank you, name me for a very nice introduction. I'm a software engineer at Google, and I'm a tech lead on the Angular project. And here with me is Rob.
Hey, everybody. I'm Rob Wormald. I'm a developer advocate, one of two now on the Angular team at Google.
Awesome. So we're super excited to be here with you today because, oh, no, my clicker's not working.
Again?
Again. Try unplugging. So we're excited to be here with you today because this is the first major event that we are attending where we can present Angular as something that is finished. We launched Angular just a couple of weeks ago. And today we're going to show you some of the features, how things work together, and how you can build awesome applications with Angular. It wasn't far long ago, at NGConf a couple months ago, when Shai actually gave this super interesting and very funny talk called NG Show. If you haven't seen it, I encourage you to go back and check it out. And one of the interesting things that he said was that you, as a community, was growing very impatient about the Angular 2 development and couldn't really wait to get your hands on it and start building applications. And one of the concerns that Shai expressed was that there seemed to be this never-ending pile of features that we just kept on adding and adding to Angular 2, adding to the confusion of what is Angular 2, what does it mean, how am I supposed to use it? So my job and Rob's job today is going to be to explain how these features fit together and how you're supposed to build applications with Angular. Great, let's get started. One of the first things we heard from you when you started working with Angular 2 was that getting started with Angular wasn't the easiest, especially if you wanted to use modern technologies like ES6 and TypeScript. Setting up build pipeline, development server, and all of this was too complicated. This is why we built Angular CLI and several seeds to make it very easy for you to get started. Rob, are we going to use CLI to build projects today?
Nope.
Why not?
So one of the things about Angular CLI is it's designed rightly to hide a lot of the complexity, right? So really what we want to show you today is kind of under the hood of how some of these fit together. The other thing that I hear a lot when I speak to developers is maybe they don't want to use the CLI, maybe they can't use the CLI in their own company. And so there's a huge portion of the developer community who's using Webpack. The CLI is using Webpack as well. So what we're going to do today is show you some of the tooling we've built for the CLI, but in a vanilla Webpack setup. So this is the kind of thing that you can plug into any Webpack app that you have, and it'll just work kind of magically.
So what should people do if they want to hear about CLI?
So Steven's doing a full talk on the CLI in a couple of hours, and that'll be a really good thing to go and watch. He'll do a real deep dive on the CLI and all the parts and the plans and whatever. We're going to show you the basic version today.
OK, awesome. So now that we have our development tools all set up, we can get started. When we are starting with building our application, we should agree what the basic building block is. In Angular applications, this basic building block is a component. Component is the basic unit of composition. It has encapsulation guarantees, and it allows us to build more and more UIs using components. So Rob, do you want to show us some overview of Angular components and what they look like?
Sure. So who in here has written an Angular 2 component so far? Most of you? Good.
I see 2 hands.
Maybe should I ask who hasn't written an Angular 2 component yet? Would that be easier? A few of you. Well, this will be really exciting for like 5 of you, and then the rest of you can hang out for a few minutes. So this is a basic Angular 2 component. You've all written one, as you said, by now. But we really want to explain to you kind of what's going on here, right? This is sort of this weird-looking @ symbol. There's some strange things going on here. So we like to break this down into 2 parts, right? So there's the class at the bottom here. This is your app component. This is where you write your business logic. This is your code, right? And then this @ decorator here at the top, this component, is really just attaching metadata to the class, right? So we're saying this is the name of the selector. That would be what you use when you use it in the DOM. This is where the template lives. This is where your styles live if you want to use those. The key here is that this is just metadata. We're not changing the behavior of the class. We're not executing anything. This is just meta information. Angular then uses that when it sort of assembles your application. But just keep that metadata in mind. So again, this is just a very, very simple component. So it's got a little bit more than it should in here. And then we've got some CSS, right? And so this is very, very, very impressive CSS that I wrote. It took me like 6 hours to make this work.
I saw him type it.
Yeah, I'm a JavaScript developer, not a CSS developer. Come on. So you were going to ask me something about this, which you forgot to ask me.
So what's cool about this style sheet?
I'm glad that you asked. So the cool thing about this is that this is a set of styles specific to our app component, right? This allows you to really write components that don't leak. You can have shareable components. They work everywhere. And it means you can put them NPM. You can share them around without kind of polluting the rest of your application. So this is the way that Shadow DOM works, the upcoming Shadow DOM spec. But Angular actually has the ability to kind of shim Shadow DOM. So if it's ready to go in a couple of years, you'll be able to switch it on without much drama. But at the moment, you can get all of the benefits of Shadow DOM without all of the, actually having to have Shadow DOM in the browser.
Cool. But what if I want to use Sass?
You can certainly do that. So there are a couple of different ways to do that. So historically, we've had the CLI does Sass for you, right? One of the things that we're going to show you today is how you could maybe do that. But in general, as long as you are feeding CSS into Angular's components, we don't really care.
OK, cool. So we saw how we can build components in our application. But one thing that we think is very important when building a rich ecosystem and thriving ecosystem is to have a pool of reusable components. Can we get one of the components from, let's say, material design and pull it into this application?
Sure.
How hard is that?
It's ridiculously hard. So we're going to do it on stage. We're going to do something really brave and do an npm install on stage here, if I can remember how to spell Angular. And we're going to bring in a couple of things. We're going to get Angular Materials core library and their card library. Luckily, I have this installed, so if this explodes, we don't have to worry about it. So we're just going to npm install. And then I'm going to jump over here to my app module, and I'm going to bring in a couple of different things. So I'm going to go and we're going to use Angular's type completions. You don't have to watch me stumble around typing like I'm doing right now.
We're still watching.
I know. And we'll get nice auto-completion. Hooray, TypeScript, so I don't have to type that out. So this MD card module, it's the same as the module we've got in our application here, but this allows us to really bring all of the stuff that material design card needs. So if it's got services or if it's got multiple directives, all of it comes in this nice MD card module. I can drop it in here. And then what I can do is switch back over to my app component here, and I've got MD card. So now this will be available to my application and should be able to use this. And I will go ahead and hit save here and make sure my dev server is running. You told me like 8 times to make sure that I had this dev server running, and I still forgot, so I'm sorry. Cool. So let's wait for that to boot up. And I've got my router outlet, so we're jumping ahead slightly, and we'll pull that out for the moment. You told me to change that as well, and I forgot, so sorry. It's too early in the morning for me on this. So now, hopefully, hooray. So now we've got a very beautiful application with my amazing CSS work nested inside of an MD card.
Cool. So we pulled in material design card into this application. And one thing we want to stress is that everything we're going to talk about today applies not only to applications, but also to these third-party components that you will use in your applications. So when we were designing many of these things, we were not thinking just about the core framework. We were not thinking just the application, but the whole ecosystem and how all this tooling and everything is going to work together. Great. So we have our basic building blocks. We know how to do composition. We saw how we can build very basic UIs. But if we just keep on piling more and more components onto the page, we're going to have a problem because we're going to very quickly run out of real estate. The easy solution to that is we can add navigation. We can add view transitions to the application and some kind of state management. And in Angular, this is typically solved through routing. If you build any Angular 1 applications, you're already familiar with routing. You know how that works. In Angular 2, we still have the routing. It's much more powerful than what we had in Angular 1. We have things like hierarchical routing. We have guards that allow you to do authentication, data prefetching. We have things like navigation cancellation, something that was not possible in Angular 1. Let's see a demo of how that works.
Sure. So anybody here used the new router yet? The third router? It's the only router now, but the third router. So let's have a look here. So we're going to go back to our app module, because this is kind of the entire core of our application. I've already got the router module imported here. So most things you're going to bring into an Angular application, router modules, MD card, whatever, it's all provided as modules. I'm going to bring them into my imports array here. We're going to do kind of a cool little special syntax here. So what I'm doing is actually bringing in the module, but also passing some configuration into it. So this allows me to, in this case with the router, set up my routes. So we're going to use a very simple setup here. And we'll say when we do it to an empty path, we're going to use a component. And we're going to do our, I believe I called it my welcome component. I'll import that in just a second. So we'll bring in my welcome components from ./welcome. See, car is way faster. I hate going after car because I feel really bad. Welcome.components, cool. And we'll cheat and do a bit of copying and pasting, and I'll grab my goodbye components from goodbye.components. It's there. See, I told you I wasn't going to forget that one. And then we'll go ahead and add a path to say goodbye, and we'll add a components in there. So the way we read this is basically when you go to a path that has an empty route, we'll go ahead and render the welcome component, or a route, I guess. We're using the router and the route today. And then we have a goodbye path, and when we have the goodbye path, we'll use the goodbye component. So if I go back to my app template here, I will add a couple of things. So the first thing we want to add is a router outlet. This tells the router, this is where I want you to render this content. This is the simplest version. It doesn't have a name, so it'll just kind of be the default container. You can nest router outlets, something you couldn't do in Angular 1's router. You can nest them very deeply, and you can have named ones. So if you want to have like a main screen and a sidebar or a chat window or whatever, you can do that really easily. The other thing I'm going to add here is a couple of anchors. So we'll add a router link here. So this is the router syntax for adding links. We'll do an empty route, which goes to our welcome, and then we will do a router link, which goes to our goodbye, and we'll say goodbye. Nobody yelled about any errors, so hopefully we will not have an explosion. Oh, we do have an explosion because I forgot to import my things. So we're using these two components. We need to declare them because they belong to this module, so we'll add the welcome components and the goodbye component into there. Hopefully now we'll have a recompile, up and running, welcome works, goodbye works. Scary demo hurdle number 1 crossed.
Awesome. So we saw.
It gets better.
So now we see how we can scale application, how we can add more views to application. And what we typically see is that people go crazy. They start adding features, they start adding views, and before you know it, you have megabytes and megabytes of JavaScript that users need to download.
They don't go crazy. They get excited.
Oh, developer advocate speaking.
Right.
One of our jobs as framework authors is to make sure that the user experience, so no matter what the developers do, is as good as possible. And this is why we try to set good guidelines for you guys so that you are off building applications in the right way. One of the things that we want to do is make sure that the user experience, especially when the application is starting, is good. Downloading megabytes and megabytes of JavaScript is not good user experience. Now, the way we can solve it is through lazy loading. Lazy loading is a technique that allows you to split your application into multiple chunks and load these chunks only when they are needed, when the user navigates to part of the application that requires given functionality and the code for this functionality. We looked at Angular applications, analyzed it, and realized that routes are actually really great natural boundaries in the application that allows us to chunk the application into smaller pieces. And Router already does a lot of orchestration of asynchronous processes and tasks, so it's a perfect place to handle the lazy loading. Let's see how that works. Is it easy? Is it difficult?
Well, the great thing is about Angular's router is that we're really, really concerned about user experience, but that means that the developer experience doesn't have to suffer either. So this is really, really straightforward to do. So let's jump back over to our editor. I've already gone ahead and created a users module here. So this is like an entirely self-contained feature of the application. So we have a users.module. Again, we're using that router module syntax. We're using forChild this time, which basically tells the router, hey, here's some more routes that I want you to actually add kind of below this module. We've got a couple of routes defined in here. We've got a parent route with a user component, and then we've got 2 other routes. We've got a list and a detail component. So this is like a nicely encapsulated feature. Everything's packaged into the module. And then to bring it into our application, we can just jump over to our main module here, add another route here, and we'll say this one goes to users. And instead of saying component directly, because that would be a direct import, we don't want to do that, we're going to say load children. So load children takes a string, and it's just going to be the path to our module. So that's going to be users/users.module. And then we do a hash here, which is the actual name of the module inside of this file, so the name of the ng module. So say users module here. So the way to read this is basically when we go to a URL that starts with users, Angular's router is going to realize that you're trying to route to something inside of users. It will go ahead and load that module, plug in its routing syntax, and basically then delegate routing at that level inside of the module. So with any luck, let's go ahead and add a link so we can get there. Go back to my app components, add another one of these. We'll do a router link. And this time we're going to go directly to our users. Users. There we go. So got a new router link here. Everybody cross your fingers for me, please. Here we go. Oh, it exploded. I told you to tell me to not remember to restart my server.
Don't forget to restart your server.
Thank you. So that will take a second to boot. We're back up and running. Let's try this again. Users, it works. Cool. We're going to pull down a list of users from the server. Apparently very, 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 very slowly. There we go. And then, so now we can navigate from one of this user lists to a user detail. We've got Ivy and her awesome hats, and one of me here, like from 20 years ago before I worked in open source, and it destroyed me. And Stephen Fluin. There's a much better picture of Stephen there for you. So this is a really nicely encapsulated feature set, right? It's plugged into a module, makes it really easy to lazy load. Just to preview that we are lazy loading this, let me just drop back to our welcome page here, pull up our dev tools. So we'll reload this. You can see it brings in kind of the app main, and then as I navigate to a user's routes, you'll see it'll pull in that feature as we need it. This feature is using HTTP. We don't need HTTP in our parent module, so we don't want to bring that in. We're just going to be very, very scoped about where we use our dependencies. This is super easy, right? I think that was very, very simple to do, with the exception of forgetting how to reset my server. And I think we encourage you to really, really consider lazy loading. Any real application is going to be, at some point, larger than is really necessary on a mobile device to start up. So lazy loading, we want to make sure it's as easy as possible for everybody to do. And I think that works pretty well.
Awesome. Let's go back to slides. So while you're building these big applications, it gets very easy to just lose the understanding of how the application is structured, what are all the pieces. And this is where it's important to be able to explore, discover, and when something goes wrong, also debug your application. This is why we partnered with a team from Wrangle. We built an extension called Augury that allows you to look at your application, analyze it, see the component tree, see the routing tree, and understand what is happening in the application. This is useful for people that are joining your team, or if you have a large application and are not familiar with all the pieces, you can use it. But better than debugging, who knows what's better than debugging? Nobody knows? Really? Testing, yes. Testing. Testing is much better than debugging because we want to prevent the issues from happening in the first place. And if you do testing right, you will significantly reduce maintenance cost of your application. We heard about that yesterday from the folks who built the NPR1 app. They have first-hand experience with this, and we have as well at Google. So testing is something that is very, very important to Angular, and it's been with Angular from the very early beginnings. And in Angular, we implemented testability and testing in several layers. We added dependency injection. DI is the thing that assembles the application. And in unit testing allows you to bootstrap just small pieces of the application in isolation from the rest so that you can actually do the unit testing that you need. We added testbed, which is a set of tools that allow you to bootstrap components and test them in unit tests. We have Zone.js, which is not only useful in production so that you don't need to call the $apply whenever you need to update the view, but we can also use it in testing because in testing it allows us to orchestrate very complicated asynchronous task scheduling and make it super easy in tests. We're going to see a demo of that in a bit. And lastly, we added tools like Karma and Protractor that allow you to run these tests, unit tests or end-to-end tests, against real browsers, the browsers that your users use, so that you can run them locally or you can run them on a CI. Let's see a test example. Cool. I would especially like to see something cool with zones. Can you do that?
You're lucky, because I prepared something for you, because I'm not so crazy to actually write tests live on stage. That would be nuts, right? So what we're going to do in this case, let's test our user list component. That thing we were looking at, we had our list of users, right? So if we look at our component real quick, it's a pretty straightforward thing, but what we're doing in here is we're actually using a user service. This is an Angular service. If we have a look at that, it's using Angular's HTTP. It's using RxJS, and it's actually making real calls to a live server, right? And so this is the kind of thing that we don't actually want to use in tests, right? We want to be able to mock that out. So if we go look at our test spec for this user list, let's start at the top here. So we're bringing in Angular's various testing utilities, so things like async and fake async. This is the thing you wanted to see. Tick and testbed. So testbed is kind of our base testing module that lets us set everything up. We've got a little delayer function here. This is just a little utility. And then I've created a mock user service. So in my real user service, I have a method that calls getUsers that does a real API call. It returns a promise. In this case, I have just an arbitrary delay here, an artificial delay of 500 milliseconds, and then we return some static data. So this gives us the asynchronous behavior without actually making a real API call. So then we'll set up our test environment. So we're going to do this before each here, and we're going to say async, and this kind of handles the promises for us. We'll go ahead and configure our testing module. We'll bring in the router testing module. We'll bring in our component. And then we'll say here in our provider section that basically when our component asks for this user service, provided this instance of the mock user service instead. So this is dependency injection in action. This is why we have dependency injection. It's really, really powerful. This means it makes it really easy to mock things out. So then I'm going to go ahead and compile my components. That works asynchronously. Async will wait for us. And then we actually drop into our real spec here. So just we want to say that it should render a list of users asynchronously. We're going to use this fake async zone, right? And so what this does is lets us, inside of this function, take control of time, basically, which I think is a pretty powerful thing to be able to do, right?
That's cool.
Pretty cool. So we're going to go ahead and create our components. We're going to get the elements. So this is the actual UI that's being rendered by Angular. And then what we're going to say is, let's make sure that when we start, we have nothing in this list, right? We've got an element. We're going to query selector for all those list items. And it should be a list of 0 length. Then we're going to jump forward 50 milliseconds in time, right? And so because we have a 500 millisecond delay in our test here, we should still have nothing rendered. And then we jump ahead 500 milliseconds in time. So now we're at 550 milliseconds. This means that we should have passed our delay here. And then we should expect to see 2 items in our list, right? So if we actually jump over to our terminal here and run this, and I've already prepared this and tested this like 8 times today, and I'm still scared it's going to fail, actually. So that's going to run Webpack. It's going to do the bundle for us. It's going to set everything up. It's actually going to run the test. And if we jump back in, we see we've got 1 test passed.
Cool. Let's look at the test one more time.
Sure.
So the cool thing about the test is that if you look at it, it looks synchronous. And actually, the code that's been executed is asynchronous under the hood. The test under code is asynchronous. But the way we're executing, thanks to Zone, we can take the synchronicity out of the picture, write the test in a synchronous way, and still have the test under the code under test behave asynchronously. This is really, really powerful. Okay.
For the next demo.
Let's go back to the
slides.
Awesome. So while testing is important, we want you to write tests only for things that matter. This is the business logic of your application. This is something that machines don't know. They don't know how your business logic is supposed to work. But what machines do know is how your application is supposed to be wired. They know about how to interpret configuration. So we don't want you to write tests for these things. This is something that Angular should be able to look at, understand, and detect errors quickly and tell you about them. This is why we have compiler and compilation in Angular applications. We take all of the metadata and all the declarative things that you specify about your application. We can analyze it, and we can look for errors. We can find errors in your templates. We can find errors in your bindings and tell you about them before you even run the code. Rob, can you break our application?
I'm a professional application breaker. Trust me, I can handle this. So let's go look at our app component. And let's say that I've never used the router outlet before, and I, for some reason, decide that I want to add a foo property to my router outlet, right? So this is, we're saying bind to the foo property of router outlet and set it to the value of whatever bar is in our class. Neither of these things actually exist, so this is probably not going to work, right? So we'll not test. We'll start up our environment again. There we go. Jump back over to our browser, and what we should see here, and this actually fires up, is a horrifyingly large error message here. But it's useful. It tells us, hey, Rob, you broke everything. So it says, I cannot bind to the foo property because I don't know anything about it. Angular looks and says, OK, I know because there's a dash in router outlet, it's either going to be a custom element or an Angular component. It's going to check the schema to see, OK, these are the inputs, these are the outputs, these are the things I can bind to. And if there isn't a match, it's going to throw up an error and say, hey, this is wrong, I don't know anything. It gives you a line number, which is super, super helpful. You don't have to poke around your application and try to figure out where it came from. And if I go back and fix this now, it should boot up and run. So the idea of this is that, we're using that metadata that you're declaring on classes when you do input and output and add component. All that stuff is just metadata that we can analyze, plug into tooling, and we're going to show you some even more cool tooling that we use that in just a second. But that's the basic idea.
Cool. Let's go back to slides. So we talked about user experience, and we're going to talk about user experience a lot today still, because that's really what makes the applications awesome, and that's why people come back to using these applications. We showed you that Angular already understands quite a lot about the application, analyzes applications, looks for errors. But not only can we use this to detect errors, we can also use this information to create fast UIs. You can write fast UIs if you know how to create really performant JavaScript code that updates the view. But even the best of us can do this only on small scale. It doesn't make sense, or it's not really feasible to write really hand-tuned code for large application because it's just too much to do. What Angular can do is it can analyze the application and it can generate code that is fine-tuned, that is optimized, and can update the view of the application very, very quickly. Can we take a look at what the differences between Angular 1 and Angular 2 when it comes to updating UIs?
Sure. So we've been playing a lot with different various benchmarks. That's a lot of my time is spent doing benchmarks and testing and things. So we've been playing recently with this dbmon. So dbmon, we'll show you the Angular 1 version first. dbmon is really a stress test benchmark. So what you've got is 20-odd rows and 5-odd columns. And what's happening in the background here is basically, the application is basically saying, as fast as I possibly can, change out some set of the data. So you can see I'm mutating 50% of the data on this page. And so you get this really, really, really stressful system for the application. It's doing a lot of UI updates. This is Angular 1.5, I believe. And so we're repainting at something like 23, 24 frames per second. I don't know if you can see that in the bottom of the screen there, which is not great, right? But one of the things that Alex in his talk mentioned yesterday is that we really want to be at 60 frames per second, right? That's our target. 60 frames per second is what everybody expects animation to run at on the web, right? So if we look at the Angular 2 version of this test, and this isn't even the fully final version of Angular 2. This is a slightly older version. We're running here, and this is running right now at 110 frames per second on screen right now, somewhere in between 90 and 110. So this is, what, 3, 4x faster at a very sort of basic, naive version of this. So significantly, significantly faster. And I think we've probably got more room in here to optimize. So
cool.
Pretty big difference.
Mishko talked yesterday about performance and how there are many aspects of performance. This particular benchmark stresses the runtime performance and how quickly can we update the view. But there are many other things that we need to take a look at. One of the things, and this is kind of ironic actually, is we need to optimize the Bootstrap latency. And the compiler that makes it really awesome to build, to generate code that updates quickly at runtime harms the Bootstrap latency. Because compiler, the more sophisticated it gets, the more code there is. All of this code needs to be downloaded in the browser. This takes time. The browser needs to parse it, load in memory. And once we get through all of that, then we need to download the application. The compiler needs to go and analyze everything, generate the code. This takes even more time. And this is the time that user is just sitting on the screen waiting for the application to finally start. In Angular 1, we couldn't do much about this because compiler was built into the core of the framework. In Angular 2, we did this big decision. We decided that compiler should be separate from the core. It should be a separate module. And this is what allows us to do something what we call ahead-of-time compilation. This is the mode in which the compiler can run outside of the browser as a build step, can analyze your application and generate the code. And then when your application starts, what you ship is actually the generated code. You don't ship the compiler. You don't need to do the analysis and the code generation when the application starts. This makes a big difference in startup of the application. And Rob, do you want to show how that works? Sure. Is it difficult?
So has anybody in here done ahead-of-time compilation with your Angular 2 applications yet? Anybody messed around with it yet? A few of you? Yeah?
A few brave souls.
Not too many of you? Cool. So one of the neat things about, so obviously the initial version of this, and we demoed this at ngconf, we had a command line tool. So you'd run something like ngc on the command line, and this would just run the build step. And we've heard from a lot of people that this is really not going to work for them in their own build systems. They want to integrate it. They want to have it watching. They want to do Sass and less and all that CSS stuff that I don't understand. So what the CLI team and I have been working on for the past couple of weeks, and I believe just got merged into the Angular CLI code base about 6 hours ago, is a Webpack plugin that does all of this stuff automatically for you. So I'm going to show you my ahead of time Webpack config here. All we've got here is a very simple Angular plugin, so we're just requiring ng-tools. ng-tools is going to be our namespace for stuff that we're using as tooling, but is not specific to the CLI. We've got ng-tools, and we go down to my plugins, and I've got the new ng-tools.ngc Webpack plugin. So all I have to tell it is this is where my tsconfig file lives, and this is where the root directory of my application lives. So if I switch over to my terminal again, and this time I'm going to run npm run, because I forget the command, npm run build AOT. So this is going to run nothing special. This is your standard Webpack config command here. So we're saying call Webpack, use this Webpack config, and then we're going to just run a server for it. So what's super cool about this is it's going to run, the first thing it's going to do is analyze your entire application. So that same metadata analysis we've been talking about happens inside of Webpack. We're running that on your components statically. So we get all the information we need. We can detect the routes. We can see all your lazy routes. And then Webpack will actually build those packages for us. So you can see that we've gone from I think it was roughly 850K on the non version to a 93K gzip version with the router and material design and a couple of different things in there. And then automatically builds our lazy bundle for us. So as well, we'll jump back over to the browser here. Let's make sure this is working, great, and then lazy loading works as well. So this is now an ahead-of-time compilation application built from the exact same code base. The only thing you need to do to change between the two modes is have a different main entry file, which is here. And so instead of, this is our original one, we're bootstrapping our app module. We'll jump over to our AOT one, and we're going to bootstrap the generated version of this code using our platform browser. This is the only thing you need to change out between the two modes. This is super, super simple. And again, this should be out in the next couple of days in the CLI. And this will work for anybody who's using Webpack. It's not specific to the CLI. So stay tuned for more info on that.
Super cool. Can we go back to slides?
Yes, sir.
So we thought about showing you the impact of this on a simple application, but it's really too simple. And that's why we're grateful that the folks from Lucidcharts actually yesterday shared this flame chart with us. This is a Lucidcharts application with lots and lots of components. And what we see here is the bootstrap of the application. This is a flame chart that shows how much time is spent, and actually most of the time is being spent analyzing the application, compiling, generating code. And this is not great. Once they turned on the ahead-of-time compilation, all of that was gone. And when we are bootstrapping the application and analyzing what that looks like, all we see is that we are bootstrapping the application and rendering the UI. This is super cool.
Big improvement.
So we talked about ahead-of-time compilation and how this can allow you to remove big chunk of Angular from the payload size of the application. But there are other things that could also be removed. As you're building large applications, you don't want to be building everything from scratch. You want to rely on libraries. You want to rely on reusable components. Unfortunately, once you start doing this, it's very rare that once you import a library, you will use all of the functionality, or you will require all of the functionality from this library. So you have all this dead code that is there. You are using just one feature, but you have to pay the cost of the download of the whole library. This is not great, and there's things we can do about it. There are tools at Google. We use Closure Compiler to do something called tree shaking. If you haven't seen Martin Probst's talk yesterday, I encourage you to check it out online. In the ES6 world, we have tools like Rollup that can do tree shaking on ESM imports. And in order for this to work, your application, the framework, and the components need to be packaged in a particular way. And this is what we did with the framework already and material design. And we are working with other third-party component vendors to also follow these guidelines so to make the whole ecosystem compatible with this kind of optimization. Do you want to show us how that works?
Sure. So as a consumer of this kind of stuff, if you're using Webpack 2 or Rollup or anything that's really modern, you don't actually have to worry about this at all. It's totally automatic and instant. And basically just turning on Webpack's production mode will automatically do tree shaking from ESX modules for you. So that's easy. If we look at something like the material design library that we're using, so I'll jump over to Angular 2 material, what we've got here is a couple of different files. So this is an ES6 version or an ES module version of the material card. So you can see it's got export statements. We ship this because this is tree shakeable. Tools like Webpack and Rollup can analyze this, again, without executing code and eliminate stuff you don't use. And then for the sake of compatibility, for the sake of people who are using older tools or Plunker or whatever, we always want people to ship a UMD bundle as well. So the UMD bundle is easy to use, right? It works with older tooling, but is not going to be the best optimization. That's always going to come from the ES6 modules. This is something that really NPM didn't support at all to begin with. I think they're moving towards that. And so we've kind of had to invent our own pattern. So far, we found that it works pretty well. And we're going to go ahead and put it in the style guide in the next couple of days, I believe, as well. So yeah, we'll look for information on that.
Cool. So you started building your application, you launched, you employed all of these tricks, your application is awesome, people love to use it, you're successful, and now you're looking to expand the reach of your application. You're starting to look, how could you get more users? And the simple thing you can do, the most impactful thing you can do is localize your application to a new language or to a new region. And this is why internationalization is important. For many enterprises, internationalization is not an optional feature. It's something that is required from the beginning. And we baked internationalization into the core of the framework. We built it based on the standards so that you can use the Angular's internationalization with existing tools. Rob, can you show us how that works? Can you localize the application to Klingon?
How about French? Can we do French? Okay. I don't speak Klingon really well, and Olivia's there in case I need help with French. So it's right there. Cool. So what I'm going to do is go ahead and look at our, I think we're using our welcome component. So what we've got here is a very simple H3 header that says, welcome and some interpolation. So all we're going to do is add this I18N attribute to this, and this is just a hint to Angular's compiler to say, hey, this is something we're going to want to internationalize. So if I jump over to my terminal here, and I'm going to do this so I don't look stupid and forget the command again. So I'm going to run npm run I18N extract. And so what this is going to do is run this ngxi18n command. So this comes with Angular's compiler. It's the command, it's the companion to ngc. What this will do is run across our templates and generate for us an xlif file. So this xlif file is basically an XML file which contains all of the extracted strings from our templates. This is a standard thing. This is not something we invented. So you can ship this out to a translation house. There are open source apps to handle this. A really cool project, if somebody wants to build it, would be an Angular app that allows you to manage translation files. Just a thought. And so what we can do then is you send this off to your translation house or whomever. We go back to our file, and what we get back is a localized version of this file, right? So this is the French localization of that xlif file. Is bonjour correct for welcome, or what should I say? Is that close enough? Cool, we'll go with that. I was worried you were going to be in the front row as I talked about this. So what we're going to do then is we're going to run I18N build I18N. And so this time, we're going to run the ngc compiler again. You can see me running it down here. But we're actually going to tell it, oops.
I18 build.
Oh, right. Oh, no, it's type checking for me. It's saying, hey, stupid, you added a thing on your component that you don't have on your component. See, this is our tooling saying you screwed up. Hello, cool. Let's run that again. So we're running the ngc compiler, and we're saying this is the translation file I want you to use. So it's going to merge these two things together, and anywhere it sees the English translation, it's going to kind of replace it with the French translation. We can say locale there, and then we just give it a tsconfig. So again, this runs through Webpack. It's going to boot up, and now we've got bonjour localized. So now we have a French binary of our application that's set up and ready to go.
Cool. This is just a subset of the internationalization support we have in Angular. There is more than translation strings. There's pluralization and many other things that we built into the framework. OK, great. So as you can see, there is a whole bunch of stuff we talked about. But I believe this is not a pile of features. The CLI allows you to get started. Components allow you to have a good basic building block and a composition model in your application. Routing allows you to scale your views and do navigation. We have lazy loading to optimize the first time rendering. We have augury and other tools to allow you to analyze and debug the application. Testability has been there from the beginning, allows you to prevent mistakes and reduce the maintenance cost. We have compiler that helps you with detecting errors, generating efficient code. And we have packaging that allows us to do more optimizations. And finally, to reach more people with your application, we have internationalization that is building. All these features have its place. They support each other and allow you to build awesome applications. So at the beginning, we talked about Shai and his talk at ngConf. And one thing that I really, really liked was that he told us that while the community was impatient while while waiting for Angular 2.
Justifiably impatient.
Justifiably, yes. On behalf of the community, he expressed that the community believed in us. There was a lot of support that we received while building Angular 2. And this was a very proud moment for many of us because we built this community to be inclusive and supportive. And we received your support when we needed it during the journey of building Angular 2. And it's really cool to be out here and say that now it's our turn to say that we believe in you. We believe that you can go out there and build awesome applications with Angular. Thank you.